Hello, everyone. Today we are going to show you some little aspects from the topic leakage. So here we go. One of the biggest problems that engineers faces in the is that the frequency which appear in their data don't line up doesn't line up with the analyzed frequency. Therefore, a leak starts to occur in the surrounding frequencies. So, what is leakage in signal processing? Leakage, more explicitly called spectral leakage, is a smearing of power across a frequency spectrum that occurs when the signal being measured is not periodic in the sample interval. So, in other words, we can see that the more exact or precise, or of the more precision you want in your sampling, the biggest leakage will occur. So what is happening? The amplitude will dip and the peak will spread out. As we already said, here we can see some examples where we can watch how the signals have some not some a little difference in between their dips and their peaks. This occurs because of the precision that some samples look for. Why does this happen? Okay, it occurs because discrete samples results in the effective computation of a Fourier series or of a waveform having discontinuities, which results in additional frequency components.
It's a pretty waited for the lines to line up perfectly. Nevertheless, these uses can be cleared up by taking more data using a technique called windowing. Window to reduce like a mathematical function called window is applied to the data. Window are designed to reduce the shared transit in the recreate signal as much as possible. Windows are typical shaped as functions that start at a value of 0, move to a value of the 1, and the return to a value of 0 over 1 frame. The capture signal is multiplied by the window as shown in this figure. Benefit of reducing lag. The benefit is not that capture signal is perfectly replicated. The main benefit is that the leakage is now confined over a smaller frequency range. It's that of varying the entire frequency, but width of the measurement. The improvement of the reduced frequency range for the lead is showing in this figure.
Hello, I will explain the example of our topic. For this example, we used MATLAB, and in this example, we will start with a sine wave at at 50 hertz, sample at 1 kilohertz with 4080 samples. and we can see the wave. No. Now we then calculate the uh, fast Fourier transform by scaling the frequency axis to be in hertz and scaling the magnitude by the square root of the length of the uh, fast uh, fast Fourier transform. And we obtain this graphic, and let's zoom around the peak at 50 hertz, and we can see better. And now we will repeat the same process, but now using only the first 4096 samples of ET and approximately 4.1 seconds, and see the graphic. As you can see, the graphic is a little bit different than other. And now let's compare the two graphics. And you can see the difference better, no? Okay, why it is happening? Well, as my classmates explained, this is a spectral leak or leakless, and basically the more resolution we have, the bigger the leak will be. Measuring a non-integer number of periods adds spectral leakage to the fast Fourier transform. And to resume, if you want to be more exactly, or to increase the samples, the leakage increase as the same that you increase the samples, basically.